All right, here we go. We're going to continue with 5.3. And this is actually going to be the most difficult type that we're going to see.
Yes.
Good, you're up for the challenge? Here we go. If I look at example 8, it says find all solutions of 2 cosine 3t minus 1 equals 0. All right, if it's not an x or a t or a theta, we're going to have to do some kind of substitution because we don't know how to solve that. So what I'm going to do is I'm going to use theta. I'm going to say theta is 3t. And then what's really neat is even though this looks like a really complicated problem, we're going to find out it's fairly simple, okay? So watch this. This is what we did yesterday, right? I know how to solve 2 cosine theta minus 1 equals 0. So I'm going to add 1. I'm going to divide by 2. And now you guys are going to just be like, wow, this is easy. So here we go. Theta prime is pi over 3. So theta is pi over 3 and 5 pi over 3. Okay, hopefully now we're getting all our unit circle down. It's really nice. It does reinforce what we did in chapter 4. So a question I keep getting is, how do you know if it's plus pi n plus 2 pi n? How do you know how to write it in general? And let me try to go over this again. This is first quadrant and fourth quadrant. If I add whatever this is around, if I add that exact same distance, I'm not here, right? I'm somewhere else. So trying to add pi or whatever that distance is doesn't work. And so that's how I know that it's going to be pi over 3 plus 2 pi n, where n is an integer. All right, now, the problem didn't have a theta in it, did it? So, what we're going to do now is we're going to go back and replace theta with 3t. Okay, and then I'll do the second row in a moment, but we're going to do them one at a time. Okay, and this is cool. This is really cool. So watch this. If I wanted to solve for t, what would I need to do to both sides of the equation? Beautiful. You guys are so smart. You're going to divide by 3. Now remember, when you divide an equation back from Algebra 1, doesn't that seem like so long ago? Algebra 1, wow. 3 years ago now. Anyway, in Algebra 1, you have the multiplication property for equations that says if you multiply one side, you have to multiply the other side. Not part of the other side, but the entire side. So this becomes t equals, and hopefully you can handle the complex fraction, that's pi over 9 plus 2 pi n over 3, where n is an integer. And then we're going to do the same thing with our 5 pi over 3. Okay, bless you. So we're going to replace theta from down here, and then you just divide by 3, and I get t equals 5 pi over 9 plus 2 pi n over 3, where n is an integer. Okay? Not bad. Not bad at all. All right, what I want you to do now is I want you guys to try example 9 on your own. What are you going to let theta equal? In example 9, what would you let theta be? X over 2. Beautiful. Then solve it for theta, and then put back in x over 2. While you're doing that, I'm going to give you a handout that we're going to do next after we finish these notes. quirky, just a couple reminders. We're going to spend tomorrow on 5.3. I have some problems we will do together. And then Thursday and Friday, we're going to be doing 5.4, which is sum and difference formulas. Monday next week, we will review. And a week from today will be our quiz on 5.3 and 5.4. Okay? Just so you know where we're going. All right, are we up to this point? We okay? So I'm getting theta is 3 pi over 4 and 7 pi over 4. You guys okay to hear? Now, let's talk about this. This is second and fourth quadrant. What is the distance between them? Pi, to get around here is pi, to pi, to pi, to pi, to pi, to pi, to pi, you know, and I can go around and around and around. So this is actually in condensed form. Theta equals 3 pi over 4 plus pi n, where n is an integer. Do you notice I don't need to do a 7 pi over 4 plus pi n, because this plus pi n includes this one, okay? Now, I'm going to solve this. Theta is actually x over 2. And then what do you need to do to both sides of the equation to get x? Multiply by 2. So this is x equals, now be careful, you do reduce all fractions. And I'm getting x equals 3 pi over 2 plus 2 pi n, where n is an integer. Okay? So you guys just did the most difficult problems you can do. Okay? That's awesome. All right, let's look at example 10. Oops, it was on the other page, but I'm going to do it here so I have a little bit more room. All right, this one, we're going to use a technique. I'm going to go ahead and subtract the 4 from both sides. We know we can't handle a secant squared with a tangent, so we should know tangents and secants go together somehow, don't they? What could we do? Yes, let's do a Pythagorean identity. And isn't secant squared equal to tangent squared x plus 1? Or 1 plus tangent squared x? Same thing. So, if I collect like terms, I get tangent squared x minus 2 tangent x minus 3 equals 0. Then I'm going to factor this. So I get tangent x, I'm going to do a 3, a 1, a minus, a plus. Let me check my work when I factor. Yep. So I'm getting tangent x equals negative 1, or tangent x equals 3. And I've done this enough that I know that theta prime is pi over 4. So from 0 to 2 pi, that's, I just did this, right? 3 pi over 4 and 7 pi over 4. That has a distance of pi. Now, tangent x equals 3. Now I want to pause here and refresh your memory. Remember, the tangent curve is repeated cycles of this curve. And so MIL 3 is not on the unit circle, right? I mean, if I could do 1, negative 1, I can do a radical 3, and I can do radical 3 over 3. But I don't get a 3 out for tangent. But like we saw yesterday with cosine, remember we had like cosine x was plus or minus square root 2, and we said, okay, you can't get that for cosine, but that's because cosine oscillated between 1 and negative 1. with tangent, it's going from negative infinity to positive infinity. So it's actually okay to get it to spit out a 3. So I can do this, but it's not unit circled. And let me show you how you can do it without the calculator and how you can do it with the calculator. So really, to figure out what x is, I would do inverse tangent of 3, right? Now suppose this is on a no calculator part. Tangent is positive in the first and the third quadrant, right? So, I don't know where that is exactly, but that's a difference of pi. So my answer is going to be, in general, inverse tangent 3 plus pi n, where n is an integer. Okay, that's really kind of interesting. Excuse me. Thank you. Now suppose I had my calculator and I wanted to get some kind of decimal, so let's take out the calculators. Check your mode. In general, you want to be in radians. The only time you don't is if the problem says degrees, or you're talking about like some kind of angle of elevation, angle of depression. Like you're not going to say, hey, let's lift that, firehouse ladder up 0.27 radians. Like nobody's going to know what that means. So, you want to use degrees in appropriate settings. So all you're going to do is inverse tan 3, check your mode. I did check it, okay. I don't know if I did. So I'm getting like 1.25. So the other answer would look like this, 1.25 plus pi n, where n is an integer, okay? So again, whether you have a calculator or you don't have a calculator. All right, that finishes our notes. So let me turn my